Hello, street leaders. Thank you for watching, and this is now question 5 of ACT Science Test 59F. It's the last question, it's the last question in this passage, because this is one of the old 5-question data representation passages, and this is an actual level 3 question. This is the quote-unquote hard question. It's hard because you don't just got to find the relevant piece of data, and you don't just have to, interpret that data, that relevant piece of data in the context of the graph, to find a relationship. You don't have to apply this relationship. You have to use the graph and apply the relationships in the graph to find a new element that's not part of the initial thing. And what's that new element? Hornfels. We're going to bring in a completely new rock out of left field that's not on the chart. And we're going to ask you to find out which fascia it would form in, because we're just going to give you, and we're going to give you numbers, or we're going to give you situations that kind of tell you where and when on the chart it might pop up. And then you got to use those numbers or those facts about reality. You have to apply real world reality to your science chart to show them you can do science. You can apply your scientific knowledge to the real world to solve problems. Sounds like fun, doesn't it? Okay, Hornfels is a metamorphic rock formed when magma, molten rock, heats sedimentary rock on the Earth's surface. Oh, that's why it's not on the chart, because, I guess because I don't know why it's on the chart. I guess it's metamorphic too. It should be on the chart. Okay, according to figure 1, we got to use figure 1. Ooh, that nasty one. We got to use figure 1. Hornfels is most likely a member of which of the following fascias? Well, now we have to use logic. Now, Hornfels is a metamorphic rock formed when magma heats sedimentary rock on the Earth's surface. That's a nice way of saying volcano. When magma shoots out of the Earth's surface, it becomes lava. When that lava lands on poor little rocks on the Earth's surface, it burns those poor little rocks into hornfels. It's sad. So, if this is on the Earth's surface, then logic would expect you to, when you apply logic, you would say that on the Earth's surface is a depth of 0. Okay? Now, if you look at the chart, there's only one, can you see it? There's only one fascias that's actually at 0 depth, and that's fascias A. Fascias B can't even get up over into there. Fascias B only starts at a depth of, 10, starts at a depth of like 5 meters, okay, or 10 meters. So there's only one fascia that starts on the surface at 0 depth, because at the surface is 0 depth. You're not deep in the ground if you're on top of it. So I'm already really leaning hard towards fascias A. However, just to make sure, in case you weren't convinced, we now have to apply more logic to our chart. Magma, molten rock, that's rock that's so hot it's liquid, is hot. When you gotta cook the rock, so when you turn the rock into soup, that's gotta be really, really hot, like inside the Earth's surface. Now, magma is hot, and hot things have a very high temperature, like way hotter than your stove. So on our chart, we wouldn't just expect it to be up here in this corner where it's like depth of 0, temperature of 0. We'd expect it to be all the way over here, like temperature 1,000 and depth of 0. And when you see temperature 1,000, depth of 0, or even just temperature 600 or 500, you're already getting a new kind of metaphor. You're already getting a new kind of metamorphic rock, and that's fascias A. So fascias A makes even more sense. The only way you get rock, the only way you get a metamorphic rock, the only place hornfels could possibly survive at the surface is when there's a very hot temperature, like 500 degrees Celsius. Boiling water is 100 degrees Celsius. So 500 degrees Celsius is 5 times boiling water. That's 1,000 degrees. That's like how hot it is on Venus or Mercury or something, or the center of the Earth. Yeah, that's hot. So, yeah, Fascia's A is the only real possibility for 2 reasons. Okay? It has to be hot because of the molten lava, so it has to be over at 1,000 or 500 or 600. And it has to be 0 because it's on the Earth's surface, so it has to be Fascia's A again. So this is double Fascia's A. Hope this made sense. Thank you for watching. Oh, Fascia's A is answer choice A too. I think I forgot to mention that on question 3. Okay, but yeah. On question 5, Fascia's A is answer choice A too. Thank you for watching. Bye-bye.